Okay, so my name is Manthan and I'm discussing today about profiling, code profilings. So code profiling is basically analyzing of data, whatever you have generated or code, like how the code flow is working, what is the timeline of your code, IO operations, console outputs, how the synchronization is working, so all those things. So you need to take care of that in able to ensure that your output is correct, right? So and you get better performance of your code, so you need to ensure how the code flow is working, timeline is working, and IO operations. So for that we need profiling. So first CPU GPU time. So for in profiling we calculate the execution time of the whole code for a particular kernel's synchronization time, like if we synchronize a particular stream in a GPU, what is the time it is taking in the synchronization. Other times like execution time of particular streams also, like a kernel is going in some stream and another kernel is going some another stream. So you need to calculate the time of different kernels. Like one way is to use the GPU based timers, right? But another way is profiling, so it will give you the time of that particular kernel in that particular stream. For memory we optimizations also we use profiling. So read write, cache memory, how much shared memory your kernel is taking, what is the latency of your code, all those things are done in profiling. So two types of profiler that basically NVIDIA provides. One is NVIDIA Nsight and another is Nsight Compute. So Nsight basically does the basic profiling, right? So basic profiling means let's say you have some you need to see the execution timeline of the code, right? So how your code is executing and what is the memory it is taking and what is the flow of the code, right? So one after other stream execution. So all that basic things are done by NVIDIA Nsight. Now Nsight Compute is just a in detail analysis, right? So let's say you have done the basic profiling of your code and you know all about the timeline of your code, like how the code flow is working, right? After that, now you want to go to like memory optimizations. Let's say you have used some shared memory and you want to know which memory is fetching, how much time is taking in fetching that memory from the global memory, from shared memory, or the latency of the code, right? For that you use Nsight Compute. So first, all according to the needs of your code, all the basic profiling is done in NVIDIA Nsight, right? So currently your all the basic profiling can be done in Nsight. You need not go to compute, but if you need, you can go to. So this is the basic picture of your this is Nsight visualization profiler. So in that you will see that basically a project area, project explorer area here. So whatever file you load, you will see the file here, so you can change according to your need. And in this area, the main area that you can see is your basically display area. Here you can do the select which part you want to profile, like you have a code, you have made some executable and you want to profile it. So in this area you select that. Now menu bar, you have all the file, view and tools. So view and tools are just basic how you want to view the profiler, but main is file. In file you will see the project, open, export, import, right? So open is basically opening a already created a profile file and you want to open it and you want to see it, right? Import export is you want to export a particular file, you have done some profiling, you mark some changes in the profiler, now you want to save it, so use export. So markers, so first of in Python you can easily install the NVTS markers using pip install. In C++ you have to include these three files and your markers will be there. So this is a basic code of Python. I hope you all know by now what is this, right? It is just generating two random numbers of array nx and y and z, 3D arrays, and it is just summing and taking the difference, right? Just a simple code, right? Now if I do the profiling of this, let's see, are you able to note anything like where is the profiling happening, where is kernel executing? Even if I zoom this part, see that you can't tell whether your kernel is where it is executing exactly, right? That problem comes in packages like Python, because you know that most of the libraries are made in C++. So there is a wrapper over wrapper over wrapper and it is called in Python, right? So when a Python executes a function, there is lots of wrapper calls and all those wrapper calls are also shown in the profiling. So to know actually where that kernel is executing, we need NVTX markers. So to do that, see, this is the code with NVTX markers. Okay, so it's very basic, like import NVTX, and at the top of the function you need to just do NVTX annotate, and some array1 is the name of the string you want to display it with. Okay, and color is whatever color you want to display it with, right? So I have called two kernels, sum and difference, right? And I have annotated it with sum array1 and difference array1, right? So now if I do the profiling, you see here that you can see easily that there is a sum array bar, there is a difference array bar, right? So now you can easily tell like this area is for your kernel 1, this area is for kernel 2. So that's why we need NVTX markers, and we need to apply that. Now in C++ it is as simple as that only, like there is a function called NVTX range start, right? So just whenever you want to start the profiling, you just do NVTX range start name string, and at the end you do NVTX range end. So similarly it will also show like in the color bars whichever name you give with that name, that this is that particular kernel. So you can know exactly that this kernel is executing here, right? So profiling, I'll tell you via two methods. First is graphical user interface and second is command line interface. Okay. So in graphical user interface, as I shown you earlier the profile area, you can see that in the whenever you open the NVIDIA Insight software, you see that these options are available here, right? So first of all, command line with arguments. In this you need to give all the like let's say your code is test.py and you want to run, so you run python test.py, right? So you want to enter here command line python test.py. Okay, and no relative paths, you need to give the absolute path. I'll show you in the video. And working directory is where you want to start your profiler, so it will save your data there. So it's better where your code is running, where your profiling is running, give the working directory same, so it will save here. Now options, here are CUDA options, GPU trace, NVTX. So whichever options you select, accordingly it will start that options while profiling, and it will take into consideration all that options, right? And you after that you need to just start and it will profile it. So let's see. So here as we can see, I have given the name above, just simple python name.py. So your profile is and here select all the options you want to select. So I have selected CUDA, NVTX, etc. Now start the profiling, it will start. So now you can see there is a very large timeline here, right? You can't see anything currently. So to see the things, just open the GPU timeline as you can see here and just pinch and zoom. Okay, so you will see all the codes timelines here. So you will see different color bars, accordingly they are named according to the NVTX markers you have given. And you can also see in the code flow down, when you select that it will show whatever it is executing in that timeline. And when you show when you also show that, there is also one more thing. Yes, so here when you select that particular kernel, here you will see a lot of information also, like what is the shared memory you are using, what are all the kernels data you are using, right? Now using CLI, it is just simple, same, just open a command line terminal and just type the commands. So in CLI basically it is given by the name of NSYS. Okay, so to check first, let us check whether it is installed or not. So it comes by default with CUDA toolkit. First we'll check with GPU installed using NVIDIA SMI. We see that 2 A100s are there. Now using NSYS command, and now this is the simple code, same code that I used earlier. So I'll profile this code here. So to profile this, let's just check whether NSYS is there or not. So we use NSYS command, NSYS. So it is there, you will see something output like this. After that, to profile, you can do NSYS profile trace. So here whenever you do trace is equals to CUDA comma NVTX, right? So let's say you are using MPI program, so NVTX comma MPI, and if you don't give NVTX, it will not take the NVTX markers into account. So CUDA to enable CUDA, NVTX to enable NVTX, MPI for your parallel program. So you need to go all those, and after that executable. So in Python it's python test.py, in C++ is ./a.out, right? So you can give that. After that it will generate that normal NSYS rep file here. So nothing to be done now. NSYS rep file is created, you need to download that file and open it in Ansite Visual Profiler. So when you open it, you will again see some timeline like this, but it is easy to now know where your code is working. Why? Because now you have profiled and using NVTX markers, right? So let's pinch and zoom in the area. So you'll see here all the markers here. So you can easily see your timeline, how it is executing and other stuff. One more thing, like their blue bar you are seeing, right? So this blue bar shows how much your GPU is being used. Okay. So let's say the blue bar is like something like wavy nature, it's not constant. So it shows that your GPU is not consistently used. It's going 70%, 20%, that 100% like that. So here it's full and consistent, right? So it means the GPU is used consistently. So all those things you can see in profiler. So you can test how much your profiling is done. And references, you can take references from these sites. So these sites you will find the NVTX markers for C, as I told you now, and all the same things. And download is from NVIDIA official site. You can download the Ansite Profiler. You need not have a GPU to download this. And in any system you can install this. It's just needed to open the ANSYS rep file. Okay. But to use the GUI interface that I showed you today, you need to have the GPU in your system, then you can use that. Otherwise you can do a command line interface profiling from any server, download that file, open in Ansite Visual Profiler. Okay. Thanks, that's for me today for me. Any other questions regarding this profiling?
If I have not NVIDIA GPU, I cannot use this.
You can use this, but it's just that you need to profile using command line profiler on any server with NVIDIA GPU, profile there with ANSYS, and after that download that file and open it in your computer using this software. So to install this software you need not have a GPU, it's just a software to opening that file.